Good afternoon, grade 10 learners and educators, and welcome to today's telematic session where we will be doing geography, and in specific, we will be looking at synoptic weather maps. Our program for today, the topics that we'll cover, we're going to look at what is a synoptic weather map. We're going to look at station models, characteristics of synoptic weather maps. We're going to look at the differences between a summer and a winter synoptic weather map, and then also application of our climate content based on synoptic weather maps. So without any further ado, let's get started. What is a synoptic weather map? Now, the word synoptic simply means a summary of the current situation. So in terms of weather or climate, this means the pressure pattern experienced in an area, the fronts, the wind direction, wind speed, how they will change and evolve over the coming few days. A synoptic weather map therefore shows weather conditions at a particular time with different conditions and features using special synoptic chart symbols. So in other words, it's a snapshot of the weather conditions at a particular point in time, and because there are so many weather conditions, we use special symbols that allow us to put so much information onto one map. So that is what a synoptic weather map is. Now, the tool that we use most frequently on a synoptic weather map is a weather station model. And I'm going to spend a little bit of time explaining to you what a weather station model is. Now, you know by now already that the weather station model shows us different elements of the weather. It shows us the wind speed, the direction from which the wind is coming, the dew point temperature at that particular point, the cloud cover, the amount of cloud cover, what the air temperature is, and then as well as the type of precipitation. Now, a weather station model is therefore a method that we use to display lots of weather information in a very limited space. Now, your teacher, your educator would by now have gone through the weather station model and the key. And if we just look at this quickly, we see that from the weather station model, we can get the wind speed from this particular one. I'll be looking at one in more detail after this, but from this particular one, I can see that the wind speed is 15 knots. And if you look lower down here, you will see that over here, that if you have a short little feather, it is a longer feather, it is 10 knots. The shorter one is 5, so 10 and 5 will give me 15. There are two longer ones, which gives me 20, and that's the symbol. Instead of drawing 5 long ones, that little triangle is what we use for 50 knots. Okay? Then, the wind direction in this case is northwest. This line here shows me the wind direction. I always speak of an arrow. I think of it as an arrow being shot into a ball or an apple or something round. And this arrow is coming from the northwest into the circle. So it is a northwesterly wind, because we know that winds are named after the direction from which they come. So this arrow is coming from the northwest into the circle, and therefore it's a northwesterly wind, and it has a longer feather and a shorter one, which gives me 10 plus 5, 15 knots. There will always be two numbers. The top number is the air temperature at that particular time. So at the particular time when this information, when this data was collected, the air temperature was 27 degrees Celsius. Now, grade 10s, please remember, the weather station model has to occupy a relatively small space on your map. So we leave out the degrees Celsius here because we don't have space for it. But when you are giving an answer, if you are asked what is the air temperature depicted by this weather station model, or what's the air temperature at Cape Town or Gqeberha or Durban or whatever the case might be, if this is the air temperature, do not forget to write the degrees Celsius. If you give the answer and you only write 27, it will be marked wrong. That answer is incorrect, because the temperature is not 27, the temperature of the air is 27 degrees Celsius. And similarly, if you are given the weather information at an area and you are asked to draw a weather station model, here again you do not put the degrees Celsius down. Now, let's skip the precipitation and go to the dew point temperature here. Dew point temperature is 24 degrees Celsius. Now, what is meant by dew point temperature? Now, you should have learned last term that dew point temperature is the temperature that the air needs to drop to in order for condensation to occur. So in other words, you have your air. In the air, there's water molecules, okay? And the air has a specific temperature. Now, you know, depending on the temperature of the air can contain a certain amount of moisture before condensation occurs, clouds form, and then it will rain. So, the dew point temperature indicates to us that particular air mass in the area that model represents, that weather station model represents. The air mass in that area needs to drop to a temperature, in this case it's 24 degrees Celsius, in order for precipitation to occur, for condensation to occur, clouds to form, and rain to fall. Now, grade 10s, can we just go back to our weather station model quickly? So in other words, let me teach you something. I'm sure your teacher told you this already. The closer these two numbers are, let's say this one here is 27, and this one here is 2. So in other words, the temperature is 27, and in order for rainfall to occur, it has to drop to 2 degrees Celsius. That is not impossible, but it is not very likely. So the further these two numbers are from one another, the less the likelihood of rainfall, the less likely it is that condensation is going to occur, clouds are going to form, and rain will form. However, the closer these two numbers, so if we look at the current situation, the air temperature is 27 degrees Celsius. With the amount of water vapor in this air mass, the temperature has to drop to 24 degrees Celsius for rainfall to occur. This is entirely possible during the course of a day to drop by 3 degrees Celsius. So the likelihood of rainfall is higher. So if in the exam you are given 2 weather station models and you are asked at which one of these 2 weather stations is the likelihood of rain more, in other words, at which one of the 2 do you think it is most likely rainfall will occur? Look at the difference between the air temperature and the dew point temperature. And the one with the smallest difference is the one where the possibility of rainfall is higher. And we can see here the symbol at this weather station for rainfall is present. And we can see the cloud cover is completely overcast. Okay, if this circle had been empty, as is the case here, that means it's clear skies, no rainfall. 1/8 cloud cover, 2/8, 4/8, 6/8 overcast. Okay, so these are the symbols for the amount of cloud cover that we have in the sky. So this is our weather station model key. Now, let's do a little activity quickly. You can just do this on a sheet of paper. So we've got to complete the table. So let's look at the first weather station model, the one is given to us. So we can see the air temperature is 18 degrees Celsius. That's clear. The dew point temperature would be the lower one of the 2 numbers, so it is 12 degrees Celsius. The cloud cover is a half, or 4/8. We usually use the fraction 8 when giving the cloud cover, so 4/8. The wind direction, once again, we can see this wind is coming from the northwest. There are 2 longish feathers, so those will be 20 knots. And then the symbol, the weather symbol, is fog. That's the type of weather, fog, the type of precipitation which is occurring. Let's do the second one together. So the air temperature, once again, it is the top number, so it will be 35 degrees Celsius. The dew point temperature is going to be 10 degrees Celsius. Cloud cover, we can see overcast, 8/8, overcast. The wind direction, the wind is coming from the east. It is an easterly wind. The wind speed, 10, 25 knots. You with me? And then the type of weather, this here is the symbol for thunderstorms. Thunderstorms is the type of precipitation or the type of weather. Let's do this one together. Air temperature, 22, don't forget, degrees Celsius. Dew point temperature, 9 degrees Celsius. Cloud cover, clear sky, 0/8. No clouds in the sky. The wind direction, it's coming from the northeast. It's a northeasterly wind. It's coming from the northeast. The wind speed once again is 25 knots, 10, 25. You with me? And this time, the type of weather, the type of precipitation, there is no precipitation. That's why there's no symbol over here. Now, a quick question. Which of these three weather station models, let's call this one A, B, or C, at which one of these three is rainfall most likely to occur, and at which one is it less likely to occur? Now, what I told you earlier falls by the way, because you can see here, from 35 to 10, the air has to drop by 20 degrees Celsius, the temperature. Here it only has to drop by 6 degrees Celsius. But remember, when we have thunderstorms occurring, very often when we have thunderstorms occurring, the two air masses that meet at the front, the one air mass is rapidly forced upwards into the atmosphere, causing it to cool down quickly. So we also need to think of that when we are looking at reasons why rainfall will occur. So it would appear in this case that there's a big gap of 25 degrees between the air temperature and the dew point temperature in this case. But remember, with thunderstorms, that rapid rising of the air being forced to rise very, very rapidly, causes air to cool very quickly as well. Right. And now we are going to draw weather station models. So I have a copy of this in front of me, and let's do this together. So our first weather station model, we have to have cloud cover of 1/4 or 2/8. So in other words, I'm going to do this very simply. If you're asked to do this in the exam, doesn't matter if you are not 100% neat with it. So that would be 1/4 covered, right? 2/8. The wind direction is southeast. That means that the wind is coming from the southeast into, let's just draw this a bit longer, into the circle. So that's a southeasterly wind. It is approaching from the southeast. The wind speed has to be 5 knots. So that would be 5 knots. Okay. The air temperature has to be 22 degrees Celsius. Remember, we only write the number. We don't write the degrees Celsius here. The dew point temperature is 16 degrees Celsius. And then the weather is fog. And that's the symbol for fog. And for this, you will get 6 marks, 1 mark for each of the elements. 1 mark for the quarter cloud cover, 1 mark for the southeasterly wind direction, 1 mark for the 5 knots, 22 degrees Celsius, 16 degrees Celsius dew point temperature, and then the weather, which is fog. Let's do another example. So in our second example, the cloud cover needs to be 3/4 or 6/8. So once again, and we shade in. So that's 3/4 or 6/8 cloud cover. The wind has to come from the northeast. So we can see that's a northeasterly wind blowing in here. And the wind speed has to be 15 knots. There we go. That's 15 knots. The air temperature has to be 28 degrees Celsius. Dew point is 16. And in this case, we have a thunderstorm forming. And that would be that particular weather station. In grade 10s, I just want to show you one more thing. When you are drawing your weather stations, it doesn't matter which direction the wind is coming from. I'm just going to draw one of 20 knots there, one of 20 knots here. Oops, made a mistake. Right, so what I want you to notice, if you are standing behind the arrow, the feathers will always come in from your right if you're in the southern hemisphere. If you're standing there, the feathers are coming in from your right. Do you see this? The feathers are always coming in from the side. Are you with me? So it doesn't matter. So if I must draw a weather station showing a northwesterly wind, so that's coming from the northwest, and the feathers will be from that side. If I've got to draw one showing a northeasterly wind, that's coming from the northeast. You see, so this arrow with the feathers is just rotating around, and they're always facing in the same direction. Okay, so I think you should now have clarity. You should now have clarity on your weather station model and how we can show lots and lots, at least 6 different weather elements in a little drawing, and we can understand what it means, and from there we can make various inferences as far as our weather conditions are concerned. Right, the next thing we want to look at is rainfall and clouds on our station models. And over South Africa, we get 2 types of rainfall. Remember, I'm just revising what has been done in class already. And we know that over the Western Cape, predominantly, and over other parts of the country, but predominantly over the Western Cape, we get what is known as cyclonic rainfall coming from a cyclone, mid-latitude cyclone, also known as frontal rainfall. And the type of clouds associated with that, if we look at this cold front over here, we know that ahead of the cold front, we will experience nimbostratus clouds, and behind the cold front, we will experience cumulonimbus clouds. And these conditions occur during winter. And this is the weather station model that is associated with it. Let's have a look at it. 14 degrees Celsius, this is the cold air behind the cold front. We know that our cold front moves in that direction, and that ahead of the cold front we've got warm air, and behind the cold front we have cold air. So the cold air behind the cold front, we can see it there, 14 degrees Celsius. It doesn't have to be specifically 14. In this case it is. It could be 11, it could be 12, whatever the case might be, but it is usually a low temperature. Then also behind the cold front, because it is raining, our air temperature and our dew point temperature, are usually relatively close to one another, and there's a symbol for rainfall, and we have totally overcast conditions with a high wind speed here behind the cold front. We have high wind speeds, and the wind is coming because the wind is blowing in there. The air is moving like that behind the cold front, and we can see that same direction of movement here, which is a southwesterly wind. And we know the southwesterly winds during winter in the Western Cape follow the cold fronts, and they bring us low temperatures, and they bring rainfall, overcast conditions, and high wind speeds. Right. The other type of rainfall that we get in South Africa is what we call convectional rain. And you know that convectional rain, we will look at this in much more detail when you get to grade 12, but convection rain falls during summer, and it comes from cumulonimbus clouds. So here we will have very high temperatures in excess of 30 degrees Celsius. We most often have thunderstorm activity taking place, and a relatively low dew point temperature. a relatively low dew point temperature and winds that come from the east, because those are winds coming from the Indian Ocean moving across South Africa during the summer months. But we look at it superficially now in grade 10, but we will look at this in much more detail in grade 12. Now, you also have to know and to be able to explain the weather conditions that we experience before a cold front moves over an area and after a cold front has moved over the area. Now, as I explained in the previous slide, that the weather changes we experience. So if you were standing here where this red dot is now, and the cold front passes over you so that you're now over here behind the cold front, what you will experience is that the temperature will drop. In other words, it will become colder, the temperature will become lower, there will be a decrease in temperature. There will be an increase in cloud cover, there will be more clouds in the sky, and precipitation will occur. In other words, it is going to rain. Those are the weather changes that can be expected when a cold front is going to pass over. So if you are listening to the radio or watching the weather on television and the presenter says a cold front is approaching Cape Town, or a cold front is approaching George, or any place along our coastline, then you know that when the cold front passes over, we will have low temperatures. The temperatures are going to become lower, so I need to dress warmly. I need to put on a jersey or a warm jacket. That the cloud cover is going to increase, so visibility is going to be poor. It's going to become darker outside, and the wind speed is going to increase. There are going to be strong winds and rainfall will occur, so I need to have a rain jacket on as well, or an umbrella, because we know that the cold front is passing over. Right, now there's a weather station showing the conditions before the cold front. Let's see if this matches up with what we said. So before the cold front, ahead of the cold front, the wind is blowing in that direction. Behind the cold front, the wind is blowing in that direction. So we have a wind direction coming from the northwest. Air temperature is relatively high, as 22. It's not hot, but it's relatively high. It's 22. Dew point is far away, 5. So therefore there's no precipitation and a 50% cloud cover. Okay? And behind the cold front, we will see the temperature has dropped. The dew point temperature has increased. The difference between the two is small. We see that there's lots of clouds in the sky now, and the wind has backed. The wind has changed direction. It is coming now from the southwest. So with the cold front, those are the two wind directions you have to remember. Ahead of the cold front, it always comes from the northwest, and behind the cold front, the wind direction changes. The term we use to say that it has changes, we say that the wind has backed, but you will learn more about that in grade 12 as well. And the wind direction is now coming from the southwest, where before it was coming from the northwest. Okay, that's enough of that. Let's move on to the characteristics of synoptic weather maps. Now grade 10s, this might seem like a lot. It might seem like, oh gosh, there's a lot of things that I need to remember and I need to know. Don't panic about it. You will learn a few of these things every time your teacher engages with you, and before you know it, it will become like second nature to you, and you will be able to interpret a synoptic weather map without any effort. It's like anything in life. The first time you encounter it, it looks difficult, it looks daunting, it looks confusing, but as you progress and as you spend more time answering questions and working with synoptic weather maps, it will start to become easier, and as I said, eventually it will become second nature and you'll be able to literally do it with your eyes closed. So let's have a look at the characteristics of synoptic weather maps. Right. So here is a synoptic weather map of South Africa, and the first thing that you need to know what are high pressure cells and what are low pressure cells. So you can see there is a low pressure cell. It's found along the coast of South Africa. The specific type of low pressure cell is called a coastal low. You don't have to know much about it now. You'll do it in grade 12. As long as you can identify a low pressure cell anywhere along the coast here, there's another coastal low because it's along the coastline. Isn't that simple? At the coast, here's the coastline of South Africa. a low pressure at the coast, coastal low. There's another one, a coastal low. They form here along the west coast, and then they slowly move all along the coastline, and then when they get over here along the east coast, they dissipate and they move away. Here's a high pressure cell. There's another high pressure cell. Right? This is the South Indian and the South Atlantic high pressure cells. Here's another low pressure cell. This one is found over the interior of South Africa, and this is called a thermal low or a heat low. If you look at the temperatures at the weather stations here, 29, 29, my eyes are bad, 27, you can see the temperatures are relatively high, they're close to 30. Right? The temperatures at most of these weather stations are high. So because of the high temperatures, because it's hot, we have a heat low. Air is busy rising, resulting in a low pressure cell, and we have this heat or thermal low over South Africa. Later on in the session, we're going to see how this is one of the things that tells me that this is a summer map. Then over here we have a special type of low pressure cell. There isn't an L here, but look at here. 1004, 1000 hectopascals, 996. My atmospheric pressure is getting lower towards the center of the cell. The highest isobars are on the outside, 1008, 1004, 1996. So because the pressure is dropping towards the inside, this is a low pressure cell. And that symbol there, and that name Eileen tells me that this is a special type of low pressure cell known as a tropical cyclone. All that you need to be able to do in grade 10 is just identify it. Easy to identify. Why? In South Africa, tropical cyclones only occur in this region here. Along the east coast, further to the north, more or less north of Durban. Durban's over there. North of Durban, usually in the vicinity of Maputo along the Mozambique coastline. So on the South African Synoptic Weather Map, this is the area where you will see tropical cyclones. So I know where to look for it. How do I identify it? I look for three things. I look for a pressure cell where the pressure is dropping and where the pressure in the middle is well below 1000, and that is definitely, because that is 996. So in the middle it's going to be at least 992, if not lower. We look for the tropical cyclone symbol, which we see there, that little squiggly symbol. And your tropical cyclone usually has a name. And these two things together, the fact that there's a tropical cyclone, the fact that the temperatures all over the country is high, the fact that there is a heat low, tells me that this map is a summer map. But we will have a little bit more of that shortly. So what else do we need to know? We need to know what an isobar is. I've used the term isobar, and it is simply a line that joins places of equal atmospheric pressure. So this particular isobar that is highlighted here has a pressure reading of 1008 hectopascals. We can see there 1008, 1008 hectopascals. So all places along that line, along that particular isobar, have an atmospheric pressure of 1008 hectopascals. Then we must be able to identify tropical cyclones. I told you how to identify it, and here's something new. The slide is telling me that tropical cyclone Eileen is the 5th cyclone for this particular season. How do we know that? Look at the first letter of the name. E is the 5th letter of the alphabet, A, B, C, D, E. If this was the first one, the name of the cyclone would have started with an A, something like Anna. If it was the second one, it would have started with a B, maybe Barbara. The third one would have started with a C, Catherine. The fourth one with a D, Dominique. Okay, they usually use female names, but I've noticed in the recent times they also use male names. So the name of the tropical cyclone, the first letter of the name will indicate to us how many tropical cyclones have preceded. So this one is tropical cyclone Eileen, starting with an E. 4 A, B, C, D have preceded it, and this is the 5th one because it starts with the 5th letter of the alphabet. Right. What else do we need to be able to identify on our synoptic weather map? the isobar interval. In other words, you can be asked, what is the isobar or isobaric, they sometimes say? What's the isobar interval of this map? Very simple. Just find two isobars that are consecutive and subtract the value of the two. So I have here 1012 and 1016. So we take the highest one, 1016 minus 1012, okay? And that gives me an interval of 4 hectopascals. So in this case, the isobar interval is 4 hectopascals. There's the South Indian high pressure cell. It will always be in this vicinity somewhere. Sometimes that center is a little bit closer to South Africa, a little bit higher, but it will always be here in the South Indian Ocean, somewhere here, the South Indian high pressure cell. During the winter months, this thing is found closer to South Africa. Okay? There is Port Elizabeth, or Kebega as it is known nowadays, and there's a weather station at Kebega, and we can see that at that particular weather station, the air temperature is 25 degrees Celsius, the dew point is 18 degrees Celsius, cloud cover a half or 4/8, wind direction, the wind is coming from the southwest at the speed of 25 knots. But you already know how to analyze that weather station model. There's a cold front. We know that cold fronts move from west to east. So in other words, as you are looking at the map from your left to your right, that cold front will move. There's the South Atlantic high pressure. And once again, during the winter months, the center, that H, will be a little bit closer to the coastline of South Africa, but it is always found here somewhere in the South Atlantic Ocean. I mentioned to you the coastal low formed along the west coast, then moves southerly direction, and then all along the coast as far as Maputo before it dissipates. Right, so those are at grade 10 level the main things that you need to be able to identify on a synoptic weather map. And you can see grade 10s, they are not a lot. Every synoptic weather map you get, try to find the South Indians. See, where's the South Indian high pressure cell? Where's the South Atlantic? Is there a coastal low? There aren't always coastal lows at the coast, but at any one time there could be 3, there could be 4, there could be none. Okay? See, where's the cold front? Ask yourself, which way is it moving? It's always moving from west to east. Is there a tropical cyclone present? Where am I going to look for the tropical cyclone? Over the Indian Ocean, in the vicinity of Mozambique, on the east coast of southern Africa. What else do you need to know about tropical cyclones? How many were there before? Does the name start with a B, a C, a F, a G, whatever the case might be? And then you can determine how many tropical cyclones have preceded this one. Okay? And that's basically, and then your isobar, you need to know what an isobar is, identify them, what's the interval between the isobars. It's usually 4 hectopascals, but it could be different, but you can figure it out. Just find 2 isobars of each other where you can see the reading of both, and then subtract, and then you'll get your isobar interval. And grade 10s, that's all that you have to know. By the time you get to grade 12, we would maybe have added 2 or 3 more items to that list. Okay? But if you can identify that, you will then be able to start using your synoptic weather map to predict weather patterns and to say what will be happening over the next 24 hours or so in any particular area over South Africa. Right, let's move on. We are now going to look at summer and winter synoptic weather maps. Now, I spoke about this earlier, and I did give you a little bit of a glimpse into what is happening and how to tell the difference, but let's do it in more detail now. So, here we have 2 synoptic weather maps. We have a summer map on the left and a winter map on the right. And one of the easiest ways to tell the difference is to check if there is a date on the map. Now, this particular summer map has a date on it, the 17th of February, and the winter map has a date on it, the 15th of June. So the date gives it away. Any date between November and February on a map will be considered to be summer, and any date between May and August on a map would be considered to be winter. Now, there aren't any weather station models on these 2 maps, but if the weather station models over South Africa, the ones over the land, have temperatures from 20 degrees Celsius and higher, it is most likely a summer map. And if the temperatures over the interior are low, if they are below 20 degrees Celsius, then it is most likely a winter map. Now, grade 10s, notice what I'm saying. I'm not saying that it is definitely, because we cannot look at one element only. I'll tell you why. If you take a condition known as berg winds, berg winds are a phenomenon that occur during winter in South Africa, where you've got an air mass blowing from the interior of South Africa across the plateau, down the escarpment to the coast. And when this air reaches the coast, it is high. The temperature is in excess of 30 degrees Celsius. So weather stations at the coastline, when berg winds are blowing, will show very, very high temperatures. But it's not summer, it's winter. Okay? So it's the same like when you're ill and your mom takes you to the doctor. The doctor doesn't just take your temperature and say, oh, you've got the flu, or you've whatever the case might be. You have COVID, you're COVID positive, or whatever the case might be. The doctor's going to look at various things. He's going to check your temperature, your blood pressure, a lot of different elements he's going to look at, and he or she, and then based on a combination of elements, your doctor will then decide, will do a diagnosis of what could possibly be wrong with you. Now, the same with this winter and summer story. You cannot only look at one weather element and say, oh, it's winter or it's summer. We need to look at what the bigger picture is, what is predominantly happening. So if there are more elements that indicate it's summer, then it's probably summer. Because during summer, it can rain in the Western Cape. It usually doesn't. But it's possible that it could happen. It happens occasionally. And similarly, during winter, it doesn't usually rain during the interior during winter. But there could be one day where everything is out of whack. And it does rain over the interior, perhaps, during the winter months. So don't look at only one element of the weather. Look at a few, and then you make up your mind as to whether it is summer or winter. But let's get back to our map. So, usually during summer, the temperatures are high over the interior and lower temperatures during winter. Cloud cover. During the summer months, because South Africa is a summer rainfall area, the interior, the land surface over the interior will have high cloud cover, and your coastal areas, especially Cape Town, will have very, very low cloud cover during summer. But during winter, the opposite will happen. Your coastal areas, especially Cape Town, will have high cloud cover, and the interior of South Africa will have very, very few clouds. Then the type of rainfall. If you see lots of thunderstorms, when I say interior, I'm talking about this part here. When you have lots of thunderstorm activities here over the interior of South Africa, lots of thunderstorm symbols, then it is probably summer. And if you have mainly rainfall here in the southwestern Cape because of the cold fronts that are passing by, you will have rainfall over the southwestern Cape, and there will be no rainfall over the interior. The type of cyclones that are present during summer, there we go, there's a tropical cyclone. But remember, the absence of a tropical cyclone doesn't mean that it's not summer. Tropical cyclones only occur in summer, but they're not there. They are not there throughout the entire length of the summer months. They are not there throughout the entire length. There are periods, there could be weeks during the summer months where there's no tropical cyclone present. So a tropical cyclone tells me it is definitely summer. But no tropical cyclone does not mean it's winter, because there are parts of summer where there aren't tropical cyclones present either. Okay? But during winter, the type, if we go back to our map quickly, we will see that during winter, the type of cyclone that is present is a mid-latitude cyclone. Now, grade 10s, let's just get something straight now. Your mid-latitude cyclones, you can see here they are on the summer map, and here they are on the winter map. So the presence of a mid-latitude cyclone does not tell me whether it is summer or winter. Rather, the location. Now look at here. Look at this cold front. Look at that cold front. They're not going, this cold front is going to go around this high pressure. You see that high pressure cell wedging in there? This ridging in here, sorry. This high pressure cell, this cold front is going to go around here, and then that way it is going to pass the subcontinent. But look at this cold front. It is going to pass over South Africa. So during winter, my cold fronts are found further to the north, and they pass over the land. Whereas during summer, the cold fronts are found further to the south, and they pass by south of the country. So remember, you cannot say it is winter because there is a cold front, or it is summer because there's no cold front. Cold fronts are present throughout the year. Rather look at where they are. Cold front, winter, summer. In winter, it's always found further to the north. So if this hand here is South Africa, here's the cold front, and it passes over South Africa. Summer, there's the cold front, it passes south of the country. Okay? So we cannot say it is winter or summer because there are cold fronts or because there are no cold fronts. Cold fronts are always there, but rather look at the location. Cold fronts are further to the north, winter. Cold fronts are further to the south, summer. Let's go back to our map. Right. A winter synoptic weather map. Here's a typical winter synoptic weather map. We could check the date. The date is over there, 29th of June. The air temperature, I'm not sure if you can see it, but the weather station models over South Africa show relatively low. The particular weather station model that we are pointing towards has an air temperature of 13 degrees Celsius, which is relatively cold. We can see the mid-latitude cyclone, and remember, it's not just that it's present, but we can see there, the cold front. There's Cape Town. That's Cape Town over there. So this cold front is well and truly passing over the country. It is found further to the north, and it is passing over the land. It is passing over the South African landmass. Okay, over the country, we can see that. There's a high pressure over the interior, the heat or thermal low pressure cell. Okay. Cloud cover at Cape Town. The Western Cape is overcast. And the interior, we notice the weather stations have clear skies, no cloud cover over the interior. And if we look at the summer synoptic weather map, we will notice that the date here in this case is in February, 22nd of February. We can see the air temperatures are relatively high. In this case, that weather station at Uppington is displaying an air temperature of 32 degrees Celsius, which is extremely high. It's extremely hot there at the moment. There's a tropical cyclone present. Once again, it's that same one, Eileen, which only occurs during summer. Notice the cold front is passing to the south of the country. It's not going to pass over the landmass. Lots of clouds over the interior. All those weather stations over the interior are overcast. And we can also see evidence of thunderstorm activity. Okay? And there's a low pressure over the interior during summer. Right. Grade 10s, I think I made a mistake here. Let me just go back. Yeah, sorry, I spoke about the heat low. Sorry. During winter, there's a high pressure cell. I was correct, I said high pressure, but I spoke about the heat low. This high pressure cell, you will know, is the color high pressure cell. I'm so sorry about that. I did make a mistake here. I just thought of that now. So this high pressure cell, which we find during winter, is the color high pressure. Now remember, your South Atlantic and your South Indian, they always, they sometimes, remember that previous map, your South Indian was found further to the south here, but they always, the South Indian is always here over the Indian Ocean, and the South Atlantic is always here over the Atlantic Ocean. But the Kalahari high pressure cell, is only found during the winter months because of the low temperatures causing air to sink over the interior of South Africa, resulting in a high pressure cell. I'm so sorry about that, but I'm glad we could clear it up now immediately. And then with the summer synoptic weather map, we find that there is a low pressure. The low pressure, this is the heat low that is found over the interior of South Africa. Right now, the last few slides before we finish up for the day, we have about 10 minutes left. So we're going to look at application. In other words, how do we apply what we have learned in class on a synoptic weather map? And these are the 5 things that we're going to have a look at quickly. So you learned that the east coast of South Africa has higher temperatures than the west coast. Your teacher taught you about dew point temperature, you learned about relative humidity, about the different types of clouds, and the different types of rainfall. And I'm going to show you now how we can identify, or how in the exam you could be asked questions on these particular topics, but based on based on a synoptic weather map. So let's just have a look quickly so that when you do get a question of this nature at the end of the year, you are able to answer the question. Right. So why do higher temperatures occur on the east coast? We know that the east coast is warmer, and if you look at this map, you can see along this coastline there is a warm ocean current flowing, the Mozambique current. So this is a mass of warm water that originates here close to the equator, and this warm water is flowing along, the same as a river would flow over land. You've got this flow of warm water along the eastern coast of southern Africa, and this movement of warm water is called the Mozambique current. It's the warm current, and because the ocean current is warm, the water is warm, the air that rests on this water mass is warm, and this, look at these winds. Can you see the wind is moving from the sea to the land? Look at there. These are all onshore breezes. They're blowing onto the shore. They sea breezes or onshore breezes. They're blowing from the sea onto the land. And as this air here moves over, as these little winds are blowing over the land, they transfer this warm air that's resting on this warm ocean to the land, and that is why Maputo and Durban and all the places along the east coast will have higher temperatures. And then similarly along the west coast of South Africa, we've got the cold water mass flowing from the South Pole in the direction of the equator. This is called the Benguela current, and here we have cold water. And similarly, the air resting on this cold air mass blows across the land. Look at Luderitz there. There's air moving in that direction. And this cold air moves over towns and cities and places along the west coast of southern Africa, bringing lower temperatures. So the difference in temperatures between the east coast and the west coast of southern Africa is determined by the warm Mozambique current, which warms up this coastline, and the cold Benguela current, which reduces the temperature on this coastline on the west coast. Then, dew point temperature, the temperature at which condensation occurs. So, as I mentioned earlier, the closer the air temperature is to the dew point, the higher the relative humidity. Therefore, the greater the chance of condensation. Condensation is where your water vapor in the air turns into water droplets, and the formation of clouds and rainfall. Okay? So, the percentage, what is relative humidity? What's the definition of relative humidity? Relative humidity is the percentage of water vapor present in the atmosphere compared to how much it could contain. So let's just say the air, remember you learned that depending on the temperature of the air can contain more or less water. The warmer the air is, the more water vapor the air can contain. So if the air can contain 10 grams of water vapor, but it only contains 5 grams, okay? So if the air can contain 10 grams of water vapor, let's just do a drawing to explain it to you. So let's just say here is a mass of air. Let's just do a simple block. And this air can contain 10 grams. The possible is 10 grams, but it only contains 5 grams. So what it can contain is 10. What it does contain is 5. So the percentage of what it can contain would be 5 over 10, which would be equal to a half or 50%. So the relative humidity in this case of this particular air mass, the relative humidity is 50%, because it's containing half of what it can contain. So let's go back to our slide quickly, and let's look at the definition again. Relative humidity, the percentage of water vapor present in the atmosphere compared to how much it could contain. So if the little drawing that I did, if that was 10 grams, if that block contained 10 grams and it could contain 10 grams, then it would be 100%, because it contains 10 of the 10 that it could contain. So here's a question. Why is the cloud cover at weather station B larger? Look at there. Lots of clouds, overcast. Fewer clouds, clear skies. So why is this area overcast? And why does this area have clear skies? because look at it, 20 minus 17 is 3. 23 minus 16 is 7. The air temperature and the dew point temperature are closer to one another, therefore there's a greater chance of condensation, the formation of clouds, and rainfall. Okay? You're with me. Now, before we finish up, we're going to quickly watch a little video clip. Oops, if you can just give me a second. If you can just give me a second. I'm sorry about the screen. This thing worked before this, and now it is not working. Add options. There we go.
Reports of widespread flooding on Wednesday morning in parts of the Western Cape, where both the Berg River and Vemesu dams are overflowing. The rivers can't hold the masses of water, and they're bursting their banks in parts of the winelands. The Cape of Storms living up to its name, with wind gusts of about 100 kilometers per hour measured early the morning in Cape Point, as well as Beaufort West. More strong winds and heavy rain expected overnight into Thursday. So here's what you can expect. That first strong cold front responsible for the widespread flooding now moving over the central parts of the country. The secondary front moving over the Western Cape early on Thursday morning with more strong winds, especially over the coast and in parts of the Cape provinces. And we are expecting gusting winds of about 70 to 90 kilometers per hour early the morning over the coastal areas as well as in parts of the Karoo, and later becoming windy as far east as the Highveld as well as KwaZulu-Natal. More widespread showers and thunderstorms will lead to flooding here in parts of the Western Cape. The ground is extremely saturated and models are picking up another 100 millimeters could likely fall on Thursday. Therefore, we still have 4 weather warnings in place for Thursday. Strong winds and high seas for the coastal areas, damaging winds over parts of the Karoo, as well as stretching as far east as KwaZulu-Natal and the Free State. And we still have that level 6 orange warning in place, where more heavy rainfall is likely leading to widespread flooding in parts of the Wineland city of Cape Town and surrounding areas. This is what you can expect on Thursday. Scattered to widespread showers in the Western Cape, over the Karoo, along the southern coastline and the Eastern Cape. And we are expecting disruptive snowfall throughout Thursday over the southern Drakensberg as well as parts of Lesotho.
So, cyclonic rainfall the lady spoke about. Cyclonic rainfall comes from mid-latitude cyclones, okay? They're associated with cold fronts. In this case, Cape Town will expect cyclonic rainfall. We can see where Cape Town is, okay? We see where Cape Town is, and we see there's a cold front approaching Cape Town, okay? There's Cape Town. There's the cold front approaching Cape Town, so we can expect frontal or cyclonic rain over Cape Town. When does cyclonic rain occur? I'm not going to go into too much detail here, but just to go through the definition, when warm, moist air from a frontal system rises up over cold air, your teacher would have taught you this work already, and as the air rises, it cools, it condenses, and then rain will form and fall. Typical exam question related to cyclonic rainfall. Name the type of rainfall at Cape Town. It's always going to be cyclonic rainfall. How do we know? Because Cape Town gets its rainfall from mid-latitude cyclones, specifically from cold fronts. Here's the mid-latitude cyclone, so it will be cyclonic rainfall. The type of clouds that we can expect to occur, the type of clouds we can expect to occur will be before the cold front approaches. We'll have nimbostratus clouds, and after the cold front has passed over, we will have our cumulonimbus clouds. And then explain how the type of rainfall at Cape Town is formed. It's when the warm, moist air ahead of the cold front is forced upwards by the colder, heavier, dry air behind the cold front, causing the temperature of this warmer air to drop, condensation to occur, clouds to form, and then it will rain. So, grade 10s, we've come to the end of our presentation for this afternoon. Thank you for availing yourselves. Thank you, educators, once again, for staying after school, for being here with your learners. Thank you for spending the extra hour. And I hope that this afternoon you learned something. Sorry about that mistake earlier, but we did clear it up. And have a good afternoon and have a good week. And grade 11s, I'm sure that you are eagerly awaiting your mathematics, your trigonometry session after this. So enjoy. Thank you and be safe. Bye-bye.